Hi everyone, Teskey here. Thanks for joining us for this breaking news story. Now, every so often, a vulnerability drops that basically cuts through the noise. Not because of the hype, but because it touches a big part of the modern stack. Now, CVE 2025-55182 is one of those. It's an emerging issue in the React server component ecosystem, and lots of the teams are rushing to understand what it means for them, what's at risk, and how fast they need to move. Now, with me is someone who spends far too much time thinking about how things break. Matt Lloyd Davis. Matt, can you give us the headline here? What exactly is going on?
Well, as you said, we're talking about a bug in the React Server Component Stack, or RSC stack. Now, that bug lets an attacker send a payload to a server and get it to run code for them. They don't need to log in or have any access already. So if the server is exposed and running a vulnerable version, then it's open to being manipulated. Now, what's going on under the hood is that React has a set of routines for handling server-side data, and the flaw sits right inside that path. So if you're building with React Server components or using a framework that leans on them, like modern Next.js apps with the App Router, then this is definitely something you'll want to take notice of.
So Matt, let's dig into that a little bit. What exactly is it about the React Server component stack that has caused this vulnerability?
Well, RSC uses an internal protocol called Flight to move structured data from the server back to the client. Now, CVE 2025-55182 sits right inside that Flight decoding path. When the server unpacks the Flight payload, it trusts part of that data more than it should. And so with the right payload, an attacker can essentially nudge the decoder into treating something that should be harmless metadata as something it should actually execute on the server. Now, in practical terms, that means a request hitting a React Server function endpoint can carry a crafted payload that ends up giving the attacker remote code execution.
Well, that sounds easy enough. Now, Matt, you've actually set this up in a lab so we can see it for real. You have a deliberately vulnerable React 19.2.0 server running in Docker, and you've written a Python script to talk to it. Now, before we hit enter on anything, walk us through what that script is doing, kind of at a high level.
Well, as you say, at a high level, the script is just a specialized HTTP client for this particular vulnerability. It takes a target URL and an endpoint and then builds the exact kind of request a React Server function endpoint expects, which is a multi-part form with the same fields that a normal server action would send. Inside that, it swaps the normal saved data for a payload that exploits the bug.
Again, that sounds pretty easy. And the interesting part is the payload itself, right? What are you actually putting in that request?
Well, the key is a pair of fields that React uses to describe a server action call. One of them is a reference and the other is a JSON blob that essentially says, here's the function to run and here are the arguments. In the proof of concept, we control both of those. We set the ID to point at a server-side function that React exposes internally, in this case, something that can evaluate code. And then we set the bound array to our own code. Now, if we're doing command execution, that sort of code, if you like, is just a small snippet that calls nodes child process execute sync with whatever command we pass in. And that's why this vulnerability matters. The decoder on the server trusts that ID and those bound values. And instead of treating them as untrusted metadata from the client, it just walks through that reference and ends up running what we've supplied.
All right, so let's see how that plays out in lab. So Matt, what are you going to run first?
Well, first I'm going to use the script in check mode. That sends a harmless payload that tries to reach a method via the prototype chain, exactly the pattern the patch is supposed to block. Now, on a patch server, that blows up and we see an error from React. But on an unpatched server, like the one we have here, it goes through and the script reports that the target is vulnerable.
So we've proved the bug is there. Let's push it a bit further. How do you turn that into obvious remote code execution, Matt?
Well, now I can switch to command mode. It's the same script, same endpoint, but this time I'm passing a system command. I'll keep it simple in this case and use who am I. So the script essentially wraps that command in a small JavaScript expression, drops it into the bound array in the RSC payload, and sends the request to form action. On the server side, React Server Components layer decodes that payload, looks at the ID, and resolves it to VM run in this context. That hands the string straight into the node process, which in turn calls child process execute sync who am I. Now, from the outside, it's just a post request, but inside, untrusted data is being turned into code and executed. So when I hit enter here, you can see the response come back with the output of who am I? Now, that's really the punchline. We've gone from a crafted HTTP request through JSON and the RSC layer all the way to arbitrary code execution on the host running this React server.
Now, just to highlight for those of you watching at home, we're turning this into a hands-on lab so you can walk through exactly what Matt's just done. Stand up a vulnerable React server, run the exploit, and then see the remote code execution in a safe environment. It's basically a playground. Now, you can poke at the bug, see what the exploitation looks like, and mess around with detection and protection ideas without risking a production meltdown. All right, so that gives us a clean picture of what's going on under the hood. Now, let's make this practical. Who actually is affected by this vulnerability, Matt?
Well, the good news, it's not everyone using React Server components. Right now, the vulnerable releases are React 19.0.1, 19.1.2, and 19.2.1. Those are the builds where the flaw sits in the flight decoder. Now, the other thing to keep in mind is that a lot of teams don't pull React in directly. They pull it through frameworks. So anything built on top of RSC, like newer Next.js projects or tools that bundle RSC support through plugins, can bring in the affected code, even if you never touch React yourself.
Those are all great points. So let's get into the part people really care about. So if someone can actually hit this vulnerability, what can they actually do with it?
Well, the impact is pretty direct. If an attacker can reach a vulnerable endpoint, they can run code on the server in the context of your application. That means they can do the things that your server can do. They can read data, change data, move laterally inside the environment if the server has broader access, or even drop their own tooling to maintain control. It ultimately becomes a question of how well the surrounding environment is segmented and monitored, because the attacker now has a reliable foothold.
Yeah, those are some scary things. So let's take a step back for a second. People see a critical CV like this one, and the temperature goes up pretty fast. How serious is this one for them, really?
Well, it is serious, but the real impact depends on how your application and your network are put together. The vulnerability gives an attacker a way to run code on the server, and obviously you always treat that as a big deal. And what happens after that is dictated by the environment that the server lives in. So if you take our demo as an example, I'm running a Node 18 Slim container that's based on Debian Slim, and it's running as root. Once the exploit lands, I can run system commands, drop a reverse shell, and do pretty much anything inside that container. Now, in the lab, that's fine because it's completely isolated and designed to be broken into. But in production, you'd want stricter controls than that. So, for example, you'd run the app as a non-root user, keep the file system as locked down as you can, limit what it can talk to on the network, and of course, be careful about which secrets it can see. The server's in a tight segment and only talks to the few services it genuinely needs, then an attacker doesn't have many options. If it has broad access to internal systems or sensitive data, things can escalate very quickly. So I'd call it important, but not an instant crisis. Once you know your versions and you understand how this server fits into the rest of your environment, you get a much clearer sense of the real risk.
That's a really good distinction, a kind of a your mileage may vary kind of thing. So let's bring this down to ground level. If a security team is listening right now and they think they might be affected, what should they do next?
Well, the first step is pretty simple. Confirm whether you're running one of the vulnerable versions of React or a framework that bundles it. That gives you an immediate sense of whether you're in scope. If you are, then move to the patched releases. The React team has push fixes already, and most of the major frameworks are publishing updated builds as well. And once that's in motion, take a minute to look at where the server sits in your environment. If it has broad access to internal systems or sensitive data, it's worth tightening that path, because containment makes a huge difference when something goes wrong. And this is a good reminder to check those assumptions. The last piece is communication. Make sure your engineering teams, your product owners, and anyone responsible for deployment knows what's happening and why it matters. These things tend to move pretty quickly, and clarity just keeps everyone aligned. And that's really it. Validate, patch, and make sure the environment around the server isn't giving it more reach than it needs. Once you've done that, you're in a good place to move on.
Yeah, that sounds pretty straightforward, as it is with a lot of these CVEs. Okay, before we wrap up, let's zoom out for a minute. What are some of the bigger lessons here for security leaders?
Well, I think the main lesson is that modern applications are built on layers of shared tooling and frameworks, and that creates a lot of hidden dependencies. You don't need to be doing anything unusual for a vulnerability like this to land in your environment. It's enough just to be using a popular framework in a normal way. The second lesson is about pace. These situations tend to move quickly, and leaders who already have strong relationships with their engineering teams tend to respond much better. So when communication is clear and people trust each other, then patching and validation become routine work rather than a last-minute scramble. And the last point is resilience. Issues like this are reminders that even well-maintained stacks can produce surprises. The organizations that code well are the ones that invest in containment, clarity, and rehearsal long before an incident shows up.
Those are really good takeaways, Matt. Okay, so that puts a bow on this latest breaking news regarding CVE 2025-55-182 and what you need to know. Be sure to check out the final module, which contains additional information for this CV. Remember, stay frosty out there, and thank you for joining us here at Pluralsight.